In this problem, I need to show that 1 minus sine theta all over the quantity 1 plus sine theta is equal to the square of the secant theta minus the tangent theta. And I can do this by starting with the left-hand side, 1 minus sine theta over 1 plus sine theta. And what I'll do here is I'm going to say that this is equal to, and here we go, the same thing again. What I'm going to do is I'm going to multiply this quotient by the same thing on the top and bottom. And what I'm going to do is I'm going to multiply by 1 minus sine theta. And the reason for doing this, you're going to see in the denominator, when I multiply 1 plus sine theta times 1 minus sine theta, and here we're using the difference of two squares formula, then in the denominator I get 1 minus sine squared theta. And that's great because in the next step I can call that cosine squared theta. Now the numerator, I'll multiply that out, and that is 1 minus 2 sine theta plus sine squared theta. Okay. So now on to the next step. And that's where I'm going to make 1 minus sine squared theta into cosine squared theta. So then I have 1 minus 2 sine theta plus sine squared theta all over cosine squared theta. Now, at this point, what I'll do is I'm going to break this up into 3 separate terms. So that gives me 1 over cosine squared theta. And you can see where that's going. That's going to turn into a secant squared theta in the next step. And then we have minus 2 sine theta over cosine squared theta plus sine squared theta over cosine squared theta. Okay. And notice that I'm keeping the theta in, every time I write a trig function, make sure that you do keep that argument, the angle, theta, in your problem. Don't just write sine, cosine, and leave out the theta. So now I can write 1 over cosine squared theta as secant squared theta. Now, the middle term is a little bit problematic, but here's what I can do with this. I can write this as 2 minus 2, and then I have sine theta, and I'll put that over cosine theta, not cosine squared, just cosine theta. And then I'll say, well, that's times 1 over cosine theta. And you can see how if I were to multiply this whole thing together, multiply across the top, multiply across the bottom, I get this fraction. And the reason why I'm doing this is because then I can call this tangent and this secant, and that's going to be helpful in the next step. Plus, and now here I have sine squared theta over cosine squared theta, so that's equal to the tangent squared of theta. Okay. So now, what can I say? All right, we have secant squared theta minus 2 times the tangent of theta times the secant of theta plus tangent squared theta. And now this is something that I can factor. And what does it factor into? Oh my goodness. Here we go. Secant theta minus tangent theta times itself, but I'll just write that as quantity squared, and that completes my problem.